Identifying Network Connectivity Issues Part 2 of 2. We're going to lead off this nugget with a discussion of a brand new feature of Windows Server 2008 R2 and is supported only by Windows 7 clients. That's called branch cache. After we do that, we'll look at more hardcore TCP/IP troubleshooting, focusing specifically on the default gateway. This is going to be your ticket out of the local subnet and beyond. There's some nice DST-related troubleshooting tips I have for you in this regard. Third, we'll look at network location awareness. In my experience, many DSTs who may have come to Windows 7 directly from XP get hung up with NLA. There is a learning curve to it. However, I'm going to break it down in really easy to understand chunks, such that by the end of this nugget, you'll know everything you need to know about supporting network location awareness in Windows 7. Let's get rockin'. Branch cache. I'm about to let you in on a little secret. Actually, it's probably less of a secret and more of just my observation in having taken dozens and dozens of Microsoft certification exams since 1997. And that is, in particular, the most recent versions of Microsoft exams, for instance, Windows Vista, Windows 7, Windows Server 2008, you're more likely to get references to new features. I swear that Microsoft uses their certification exams, albeit to a smaller degree, but still present, as a mechanism for ensuring that their certified professionals are fully spec'd up on new features. Now that's neither good nor bad, that's just the fact. In this case, we're going to look at a new feature of Windows 7 and Windows Server 2008 R2 called branch cache that, while it's difficult to set up and the specific setup steps are beyond the scope of the exam, you may see a passing reference to branch cache, so I want to make sure that we cover it from a schematic level, and we'll do that now. Are you familiar with a web proxy or a proxy server? Microsoft has their own proxy. They used to have a product called Proxy Server 2.0. Then that became subsumed by their ISA, Internet Security and Acceleration Server line. Purposes of proxies are manyfold. One of them is to act as a content cache for network users. In other words, you might have an ISA server, proxy server sitting at your network's perimeter whose function primarily is when a user inside the network, let's say, requests access to google.com, or let's say more specifically, goes out to the Apple website to grab the latest version of iTunes, assuming that you're allowing that kind of thing on your network, that is. The first request will pass through the proxy server, and the proxy will go out and actually fetch the software on behalf of your inside users. Hiding your internal IP infrastructure is another advantage of proxy servers, by the way. But the proxy server will fetch that file, which could be a sizable file, maybe 50 megs or more, bring it down, give it to the user, and store the file locally in its content cache. The idea then is as subsequent users make the same internet request, the proxy server is able to deliver the requested web pages, executable files, images, etc. at LAN speed. So you're saving yourself network bandwidth and you're improving the security of your network. Now, the idea of branch cache is to take that proxy server content cache idea and focus it more specifically in the business network. The goals of branch cache caching are basically the same as what you'd use an internet proxy server for, to decrease your wide area network utilization and to increase client access speed to corporate resources. Now, depending upon how familiar you are with Windows Server 2008, you might be familiar with the RODC, or the Read-Only Domain Controller. This is also called in Microsoft literature a branch office domain controller. More and more, Microsoft is tailoring their products for distributed environments that involve, say, a headquarters physical location and one or more branch office locations that are separated from each other and the headquarter via WAN, or wide area networking links, which by definition, in most cases, unless you have something like Metro Ethernet, are going to provide much slower speeds than what you have internally within each site. Now, Branch cache, as I've already said, is limited to Windows Server 2008 Release 2 and Windows 7, so you're only going to be able to take advantage of this if your shop is fully up to date in terms of both server and client operating systems. And what it does, it functions over standard protocols, your HTTP, your standard issue web protocol, hypertext transfer protocol. You can add security using SSL and or IPsec. IPsec could be used for server message block or SMB communications. So you've got flexibility in protocols here, and the reason why you have a LAN sharing protocol and a web sharing protocol is that you might deploy branch cache not only for file shares, but also for your web applications, your intranet website. More and more, the frontline latest editions of Microsoft Server products have native built-in support for branch cache. For instance, SharePoint 2010 is a good example of a web application that interacts with file shares that's fully branch cache enabled. Now, how does this technology work in practice? Here's the deal. Let's say, as you see in my diagram up here, we have a 3-site corporate network. The 2 branch offices are separated from headquarters via WAN links. And in our headquarters location, we're going to deploy file-based services as well as web-based services for the entire organization. The way things work without branch cache, of course, is that folks in branch 1 and branch 2 have to go through the cloud to access any resources, like I said, file system, shared folders, or web application resources. That's going to involve WAN utilization big time. There's also the lack of redundancy. If one of these WAN links were to go down, then the branch office folks would lose access to those shared resources. And finally, there's slow access speed. How to fix this? Bring up one or more branch cache content servers. So we would bring up a branch cache server in each site, and the local branch cache server sitting on each branch office subnet would act as a proxy for any branch cache shared resources that are stored in headquarters. Such that, for instance, let's say you have 2 users in branch 1, and one requests a 100 megabyte file from headquarters. The very first time that file is requested, it's similar to the scheme I gave you when I talked about the web proxy. The local branch cache server does not store the whole corpus of branch cache enabled file and web share information. It's done on an ad hoc basis. So the first user requesting the file from branch cache, this local server will go out and fetch the resource from headquarters, bring it back. So the first user kind of pays the penalty for the rest of the network. His or her access to that file is going to be as slow as it normally would be. However, subsequent users in that branch office who make requests for the same file will receive that file at LAN speed because our branch cache content server here has, you guessed it, cached that material to its file system, you see? That in a nutshell is how branch cache works. Typically, branch cache setup is something that your systems engineers, systems administrators are responsible for. So as an enterprise desktop support technician, we're focusing chiefly on client-side configuration. And as I said earlier, for the 7685 exam, I just want to make sure you understand the basic mechanics of how branch cache works. Now, to get this thing set up in a very 1,000-foot bird's eye view, on the client side, you number 1 have to enable branch caching. Makes sense, right? Typical way to do that in a domain environment is to deploy branch cache settings through domain group policy objects, or GPOs. Now, if you're running Windows Server 2008 prior to R2, you're not going to see the branch cache group policies. Remember, you have to have your servers up to the Release 2 standard in order to access this technology. You can also set and manipulate branch cache settings locally or in a script fashion using the network shell command. We discussed this in some little bit of detail in the previous nugget. The second thing we need to do on the client side is make sure that Windows Firewall is set for the appropriate exceptions or allowances for the appropriate branch cache protocols. For instance, HTTP, the WS Discovery Protocol, and again, we can do that through Windows Firewall domain policy and group policy, and we can also use Network Shell or just the Windows Firewall with Advanced Security Console on an individual machine if you're in a smaller branch office where you're not deploying GPOs to them. On the content servers, you want to install Active Directory certificate services as well as branch cache. Certificate services is necessary because, especially for web application branch cache use, we're using certificate services and X.509 digital certificates for integrity, authentication, and confidentiality as usual. ADCS is a Windows Server 2008 role. Branch cache is a feature. Of course, we have to install this feature as well. Then we're going to configure your web applications and your file shares. You can do a lot of the branch cache stuff on the server using various net shell commands using the branch cache context. And you need to make sure group policy is set up as previously discussed. Admittedly, this is a super high-level overview. If you want to know more about the details of branch cache setup, of course, Microsoft TechNet should be your first line of support to that end. Now, what about the default gateway? In the previous nugget, we talked about the minimum configuration required to bring up a host on a TCP/IP network. Remember what those two numbers were? Remember, there was the IP address and the subnet mask. Now, that's all well and good as far as single subnet computing goes. However, there are various reasons why we would want to partition our LAN into multiple segments or collision domains. Now, beyond our scope to really get into the nitty-gritty of why we would subnet, let's assume we already have that infrastructure partitioned. As you see my little diagram, my wife calls my little ad hoc network diagrams spidergrams because oftentimes they remind her of some science fiction-based spider, arachnid, whatever you want to say. Regardless, you see in my diagram I have a default gateway. Remember, a default gateway is nothing more than a router, okay? It's a layer 3, an OSI layer 3 device that breaks your network up into multiple broadcast domains. A layer 2 device like a switch breaks your network into separate Ethernet collision domains. The router actually creates separate broadcast domains. And that's one good reason actually for partitioning a network, to increase the efficiency of network traffic flow throughout different aspects or areas of your organization. So in this diagram, this router has 3 interfaces connected to 3 IP subnets. I'm just arbitrarily calling them .1, .2, and .3. The default gateway, as I said, is going to be your ticket out of your local subnet. Your local subnet is, as I said, a broadcast domain. So if your computer were to spew packets using the broadcast IP address, which is all 255s, by default, those screams in the night, as it were, will never go past the local subnet. If we have any need to communicate with a host on another subnet, whether that's a server or a client machine, or alternatively, we could have a router interface that takes us out to the net, we need to have a default gateway. Consequently, let's take a look at some snafus or problems that can happen. Basically, the most common problem you'll see if a user can't get out of their local subnet but can communicate with other hosts on their network, you want to look and verify their subnet mask. If they have a misconfigured or absent subnet mask, then it stands to reason that their PC is not positive, so to speak, as to which subnet it is on, much less the subnet that any other host with which the computer wants to communicate is on. Okay? So we want to make sure that our subnet mask is correct. We also want to make sure we're pointed to the correct default gateway interface. One clue, your default gateway must be on your subnet. So in this case, let's say we've got the 192.168.3 net here, .1 and .2. In order for this guy to get out, you're going to have to configure this guy with a default gateway interface that's addressed in the .3 subnet, likewise .1 and .2. You can also say that we need to make sure that folks in this subnet have the near side router interface that points or faces to their subnet. In other words, to state it yet a third way, your default gateway address has to be within your broadcast domain. Got it? Now, how do you configure clients with default gateway? We can do static assignment. Of course, that's prone to human error, and this brings in the whole notion of misconfigured subnet masks. More commonly for client computers, we're going to use, again, dynamic host configuration protocol, and we can set a scope option. It's option 003 specifically, called router, and we can give that near side interface address and attach that to our DHCP configuration package and away we go. Whereas ping is the chief line of defense for the DST to test initial connectivity both to the local host as well as to remote hosts, traceroute, which in the Unix, Linux, and Mac OS world is spelled correctly, R-O-U-T-E. Here in Windows we have this silly now convention of using maximum 8-character file names for executable code. We have trace-RT. We still call it traceroute though. You may have used this. It's important that we understand how it works though. Traceroute is a command line tool that we can use to not only test connectivity between us and our target, but specifically trace the route that those ICMP packets take from source to destination. Specifically, what's happening in the background is that in the IP header field of those Internet Control Message Protocol packets, you wind up with ascending time-to-live values. So in other words, if we're doing a trace route to this target host over here, and it's assumed, of course, you see R1, R2, R3, that these guys are on completely separate IP subnetworks, that first, the packet that comes out with a TTL of 1, it hits the first near-side router interface. The router is configured, as most routers are by default, to decrement that TTL. So 1 minus 1 equals 0. R1 will send a message or an acknowledgement back to the source saying that the TTL is expired. ICMP time exceeded is the specific name for that. The source then sends out another ICMP packet, this time incrementing the TTL to 2. So we can pass through the first router on the way to the target, hit the second. Now remember, R1 is decrementing, so if we start with a TTL of 2, it's 1 by the time R1 passes it on, and then when R2 receives it, we get down to TTL expired, and we get the packet back. This continues with the source computer incrementing the TTL, and the routers decrementing the TTL, until either you get a breakdown and you get a host unreachable message, or you finally are able to resolve the target. Now, what's the benefit of this? Two main things. One, you can see specifically the path that you have between yourself and the remote host. And if you own these routers, if they're internal, it's all the better because you can manage them, tweak them, and optimize them. If you're going out onto the internet, you can see your ISP's routers, potentially internet backbone routers, etc. So seeing the path is important for troubleshooting. The second thing that's just as important, if not more, is that you can determine latency. You can see the relative speed that you're getting these returns from the routers along the path, especially if you wind up with a breakdown. You can more closely isolate where latency is occurring in the path and which router in the chain, as it were, is having problems. And that's especially helpful if all of these routers are within the fabric of your organization, because you can then resolve the problem yourself instead of having to contact your internet service provider or another third party. Let's have a look at network location awareness, shall we? Network location awareness, or NLA as it's abbreviated, is a technology that was introduced in Windows Vista. It's supported by Windows Server 2008 and obviously Windows 7. And if you're not familiar with it, and especially when you migrated from XP to Vista, you're probably a little bit freaked out at first like I was. When your network interface came up for the first time, you were prompted to associate that connection with a location profile. And your choices are, well, if you're not connected to an Active Directory domain, your choices are private or public. Once you join a computer to an Active Directory domain, at least while you're connected, the domain location becomes the active one. Now, what's the deal with these location profiles? Stated really simply, friends, network location awareness applies different Windows firewall with advanced security rule sets depending upon the type of network to which you're connected. Now, how does your workstation know which network it's connected to? Well, considering for a moment that you're not part of an Active Directory domain, the first time that interface comes online, you're actually prompted for a location, as I just said. Public and private, as the word public itself would lead you to think, this is the profile you'd want to choose, for instance, if you had a laptop and you were associating with a public wireless access point. Maybe you were in Panera Bread or Starbucks or in an airport. The public location profile is going to cut off your discovery features, your network discovery features, and apply a much stricter default Windows firewall rule set, because the idea here is you're connected to an unsafe network environment. You're connected either directly to the internet or, even more dangerous, as I said, a public Wi-Fi or public shared network where you don't have the benefit of corporate security. The private location, on the other hand, is used when you are, for instance, protected from the outside world, the public internet, by means of a network address translation device or a router. And for home users, I know that I certainly have a Linksys wireless router at home. This enables me to provide some firewall security to my internal network, as well as, most conveniently, to allow other devices on my home network to come online. Nintendo Wii, Xbox 360, my laptops, my desktops, and so forth. In a corporate environment that's not using an Active Directory domain, you would select private as well, because the idea here is you do have some sheltering already from dangerous outside influences, if I could put it that way. So you've got network discovery turned on, and you have less strict Windows firewall rules. The good news is that as long as you're an administrator, you can always change the location profile to which your network interface is attached. The game changes if your computer comes online as a member of an Active Directory domain. At least while you're connected to that domain network, the domain profile trumps any other settings that you might have set as a local machine administrator. Of course, the great benefit of this is we as Active Directory domain administrators can customize those Windows firewall rules to allow incoming ping, to bring in some troubleshooting that we talked about in the previous nugget or two, to allow certain application level protocols so our line of business applications function, and so on. Network location awareness relies upon the NLA service, so that's got to be started on your workstation. And this NLA is dynamic insofar as, let's say you have a domain workstation that's a portable computer, a laptop, such that during the day you log on to the domain, and that could be, say, a 10 private address. When you get home with a laptop and fire up the computer, you're going to pick up an IP address, let's say, from your local router, and that's using a 192 address. What's cool is that once you establish a profile for a network interface and an IP address range, then the operating system can dynamically apply those Windows firewall rules based on the location. So after you initially specify your home network is private, you can go home, log on, and you're automatically in the private space. You go to work, you're automatically in the domain space. You take your computer to Bread and Company, associate with their wireless. That's coming from a new, unrecognized network. So you're asked to associate a profile. You'd want to be safe there and choose public. Now, a nice feature addition with Windows 7 and Windows Server 2008 R2 is that we can finally have different profiles for different network adapters. It used to be with Windows Vista, let's say, that if your Vista machine was multi-homed, it had two network interface cards, there was a point of confusion here. Because what if you had one network interface connected to a public segment and another network interface connected to a private? Well, Vista would apply the most restrictive policy to avoid a collision. Windows 7 and R2, you actually can associate separate profiles to different network interfaces. That's kind of cool. In this demo, we're going to do some default gateway configuration and basic troubleshooting, and then we'll look at network locations, both in a domain environment as well as a workgroup environment. We'll examine Windows Firewall in some detail, both the local control panel as well as group policy options. Okay, let's start this demo by looking at default gateway configuration. We're on WinNugget, Domain Member Windows 7 box. We'll open the Network and Sharing Center by right-clicking the Network option in the Start menu and selecting Properties. As you can see here, and we'll talk about this in greater detail in a few minutes, you'll see that I have two network interfaces up on this system. One that's actively connected to the 10. network, that's our nuggetlab.com domain, and I have a second network interface that's not connected to anything. So it defaults to public network, but I wasn't given a choice here because it's not a live link. More on that again in just a second. For now, let's come to Change Adapter Settings, and let's look at our nuggetlab.com item by right-clicking and going to Properties. We'll then drill into our IPv4 settings, and here we go. In a static configuration, remember we need IP address and subnet mask at the very least. If we're going to register with DNS to do name resolution, we'll want to provide a preferred DNS server address as well. And then to get out of the local network, we need to provide a default gateway IP address. This is the near side router interface. And note that its network ID portion matches the network ID portion of my IP address. Now in this case, I'm using an 8-bit subnet mask, so only the first number represents the network. So our gateway is also on the 10-dot network, so we should be able to get out just fine in this case. If we were going to do dynamic configuration, then we would install and deploy DHCP on our server and make sure to specify option 3 for router. I'm going to open up an administrative or elevated command prompt and let's get going. If we just do an IP config with nothing else, it's going to tell us for our connections, let's see, the one is disconnected, we already know that. Connection 2 is the one that's disconnected. I've statically assigned 172.16.zip.100 with no default gateway. For our default local area connection, it gives us our default gateway with that. No big surprise there. Now, a couple other command line tools that you should be aware of that I didn't mention in the previous nugget that I want to mention now. First is get MAC. This is especially helpful if for whatever reason, maybe you're doing a DHCP reservation, whatnot, in Windows, that you can obtain the MAC or physical address of all network interface cards on the machine. In this case, remember I've installed 2 network interface cards. I'll need to determine the transport name or the specific name that maps to each NIC in this case to figure out which is which. Of course, another easy way to do that would just be to run ipconfig, and we'll see our tunnel adapter here, OC7, OC7. This must be our default local area connection. A few different ways to get that information. GetMAC is cool because you can also pass in the IP address of a remote system. You notice that the S parameter does that. So if we say GetMAC, and then these are case-sensitive options, DC Nugget, there's a pause as GetMAC goes out and fetches the physical address of those network interfaces. Again, the transport names are a little bit wonky, but you get the general idea. I also mentioned earlier in TCP/IP troubleshooting the importance of the ARP command. Remember, ARP functions with your IP protocol stack to fetch the MAC address in advance of data exchange communications between systems. With Windows ARP, ARP-A is going to give you your current ARP cache, and notice that if you have more than one interface, or you're multi-homed in other words, you're going to have separate caches per those interfaces. It makes sense that I have 10.0.0.1, that's our DC Nugget server, and then there's also some broadcast and multicast based options as well. Sometimes you'll need to flush the ARP cache. Good example of that is if you had to swap out a network interface card on a server, the client machine, if it's just up and running the entire time and hasn't been rebooted, is going to contain a stale ARP entry for that old network interface. You can flush individual hosts from the ARP cache, or you can flush the entire thing. Traceroute has a few options to it as well. If we throw in -D, you're not going to resolve addresses to host names. I do prefer to have that resolution take place so we can see any associated DNS-friendly names instead or in addition to just raw IP addresses. So I'm going to trace route to a remote address. Remember, we're on the 10-dot network. We're going to go through our default gateway and attempt to trace the route to a remote IP that exists on a different subnet. This was a very simple trace route because really behind the scenes, DC Nugget, our domain controller, I set it up as a routing and remote access service IP router. So actually DC Nugget has as its far side router interface 192.168.1. So you can kind of tell that looking at the trace route because the times are so short, less than 1 millisecond, almost instantaneous. And the target host is DC Nugget. And if we know DC Nugget is our domain controller, well, we know everything there is to know about this particular trace, don't we? Let's now turn our attention to network location awareness. This takes its chief manifestation again in the Network and Sharing Center. And as I said, the very first time a network interface comes up, excluding the domain option, you have the ability to associate a network with either public or private network location / Windows Firewall profiles. Now, like I said, this 172.2 interface is not live. It's actually not connected to anything. So Windows 7 is defaulted to public network, and it's not giving me the option to change from public to private because it's not up yet. Once the network comes up, if we click the icon, we'll be able to change the name from unidentified network to something more friendly, and Windows will actually let us change the network icon as well. If I click Merge or Delete Network Locations, this enables you to collapse existing profiles or delete ones that are unnecessary. You'll notice that we have two types of network locations, managed or unmanaged. Basically, your domain profile is a managed profile and you're not allowed to delete or merge that. If I select the other one, I can delete that out if I don't need it or don't want it to show up in my list anymore. That would be this second guy right here. Now, in the domain environment, where do these profile settings exist? To answer that question, why don't we fire up our RSAT tools. We'll open up Group Policy Management. We'll pop open our, for the sake of conversation, default domain policy. The path to that is Computer Configuration, Policies, Windows Settings, Security Settings, Windows Firewall with Advanced Security, Windows Firewall with Advanced Security. If we select the root node there, we see this really nicely formatted page that tells us at a glance which profiles are configured. Profile is not configured for the firewall. You can do IPsec security, Internet Protocol security, by setting up what are called connection security rules. Other than that, you can deploy specific inbound and or outbound rules just by right-clicking and selecting New Rule from the shortcut menu. Another neat thing about this is that you can import Windows Firewall rule sets to save yourself some clicking. Anyway, that's where we would, as a domain administrator, set up group policy to cover this thing. On the local machine here, on the domain workstation level, if I type Windows Firewall in the search box, we have the Windows Firewall control panel, which you'll notice most of this is shield protected, and it gives us our summary here, domain profile, private, and public. Of course, public is connected because we have that 172.unidentified network there. Home or work private networks, it gives you a nice summary of what's going on there. And then domain, this is our managed connection, and it gives us a link directly to which domain we're attached, and so on. So that's that. You can change notification settings as long as you're an administrator to determine how verbose firewall is. Turning Windows Firewall on or off. Obviously, you'd want to set this policy in group policy in a corporate environment and prevent users from making those changes for sure. We'll come back, and I also want to just dip in and show you, if you haven't used this, the Windows Firewall with Advanced Security console. Same basic settings as we just saw in group policy, only here we're manipulating the settings on a local machine, especially helpful in a work group. Same idea, it gives us the overview, which profile are active, which profiles are inactive, and then we have inbound rules and outbound rules. Here they're actually pre-configured based on what you've got going on in terms of your connection. In order to force the appearance of this Set Network Location dialog box, I unjoined WinNugget from this Active Directory domain, nuggetlab.com, and I rebooted. Now it's come up, seen that we have a live network connection, but because we're no longer associated with an Active Directory domain, Windows is now prompting us to apply the correct network settings, and we know that's Windows Firewall rules based on the network's location. And I think Microsoft does a really good job of explaining these. For instance, if you don't recognize all the computers on the network, if you're in a coffee shop or airport, this is a public network and is not trusted, you see? I'm going to choose work network in this case, and you notice down at the bottom there it just said treat all networks as untrusted or trusted. I would advise against selecting that. It's best, in my opinion, for you as a computer administrator to specifically choose which network profile goes with which network type. Tells us the network location is now work, gives us a generic name, Network 3, and we can view or change settings in the Network and Sharing Center, which we'll do right now. Now you notice that Network 3, our 10.network, we can verify that by clicking Local Area Connection and Properties, and TCP/IPv4, yes, it's our 10.network indeed, but we're in a work group now rather than a domain. You notice that this work network tag is underlined, so we can actually change the location for this. To repeat for like the 5th time, this identified network is not allowing us to change it because we haven't yet brought up that network. It's not actually connected to anything. We click the icon, we can assign a user-friendly name to this connection, Workgroup Network, and we can change the network icon if we want to as well. I'll change it to a coffee cup so it's different from the icon that's used for Active Directory domains. If we want to change the association, we can click the name, and that just simply brings us back here. That's about everything you need to know about network location awareness. Identifying network connectivity issues, part 2 of 2 review. We covered quite a bit of ground in this nugget, leading off with a discussion of branch cache, which, as you know, is a new feature in Windows 7 and Server 08 R2 that now we know provides conservation of WAN bandwidth and an increase of response time on the part of clients or users, however you want to say that, requesting network resources from, say, a branch office to a headquarter location. Next, we looked at the default gateway, what it is, how it works, and how to troubleshoot, and then we finished with network location awareness, or NLA. I especially hope that this piece was enlightening to you, especially those of you who are DSTs coming from XP directly to Windows 7. I hope that this has been informative for you, and I'd like to thank you for viewing.
American dream.